In this video, we're going to destroy this statue. Hey everybody, welcome back to my channel. My name is Bryan, and in this video, we're going to go ahead and destroy this statue as part of our fracturing series here on YouTube. I am going to go ahead and take this to the next level and take what we have already explored and learn a few new things so that we can actually start destroying some pretty cool objects. So without any further ado, let's get started. So I have this object in Houdini. I just have this statue head, we'll call it. Feel free to use whatever asset you like. This is the one I chose because it has some complexities to it. And maybe as I do this, you guys will actually have some ideas to solve some of the problems you have. So here's the setup. I just sized it down, and then it came with UV, so I deleted it for now. I'll probably end up re-UVing this later. In a later video, we're going to cover how to UV fractures. What I want to do is I want to actually set this up so it breaks twice. So to do that, we'll just start with our standard ISO offset. Let's go and wire that in. I'm going to go ahead and go up to 100 sampling divs. There we go. 100 sampling divisions works really well 90% of the time, so I just default there. We'll do a scatter here. And for this fracture, I don't need a lot of points. So what I want to actually do is lower this down to, let's say, 100. This will be my first fracture. I want big chunks, and we will go from there. Now, one thing is for sure, I want to make this completely procedural down the line. So what I'm going to do is I'm going to create a null here. And on this null, let's go ahead and name it fracture controller. Give it a color. We'll call it blue. Oh, sorry, blue. Okay. And we'll come up here to the edit parameter interface. And let's go ahead and add in a integer here. So let's just add in this integer. And I'm going to call this initial detail. And we'll call this initial detail like that. We'll hit accept. And then what I want to do is actually, to make my life easier, let's go ahead and set up our viewport so that we can actually move a lot faster. I actually have a save setting for this, but let me show you guys how to actually set this up. If you come over here, you can go to split pane left and right. I'm going to do the exact same thing down here, split pane left and right. Let's go ahead and just give myself some more real estate. And then if I come over here, you'll notice these thumbtack icons. I can right-click them and set them to link to each other. So these two will be 1, these two will be 2, and I'm going to set this one to 2 for now. And now what this will allow me to do is I can come in here and go on my scatter node. I can click on my interior detail, and I'm just going to simply click, drag this over, and relative channel reference. And now it goes down to 0, of course, so I have no points. And now I can set my initial detail to where I would like it without having to find this node later. And we'll keep adding parameters as we go, so this becomes completely procedural. So like I said, we're going to start with, let's say, 100 here. That might be a little bit too much for this, but we'll see what it looks like. And then I'm going to drop in RBD Material Fracture node. Now on this one, what I want to do before I wire it, let's come down here and just go ahead and click on input points. And I want to actually get rid of the second fracture here. And on the first fracture, we're going to call this main underscore fracture. This is going to give me my fracture ID, and we'll also move over to my constraint tag later when we set, since we have use tags clicked on. Let's go ahead and wire this now. And let's cook this up. So anyways, I have my fractures. You can see it right here in the lines. To see this better, I'll throw null down. And then you can actually see the detail via the constraints. So you can see that we do have pieces, and those are the constraints. So I'll get rid of this for right now. Could have thrown an exploded view down as well. So we'll do this. And it's handy to have an exploded view ready to see what we're actually doing. And there is our initial fracture. Now, I'm not going to do too much with this just yet. I actually just want this to be a little bit on the chunkier side. I do want a little bit of noise, though, inside the interior detail. So let's go ahead and go over here to the detail. And I am going to turn on interior detail for first, and then I'll turn on edge detail. And there we go. If I just turn on the interior detail, you'll see that we get these nice pieces that have a little bit of breakage on the inside. I do have quite a bit of geometry though, so let's take a look at this real quick, and you'll see that we have over 881,000 primitives. And this is because of the level of detail of my file. So if you look at this, you'll see that there are 499,000 primitives. That's a lot. So whatever object you decide to go with, you're going to want to make sure that you have the resolution properly set. Now, I have a couple of things that I can do to de-res this a little bit. One of the things that I can try and do is use a poly reduce node. The only thing is, be aware that this node is going to take forever to cook, but what I could do is lower the percentage of the faces here. Let's say we want to go down to 50% of this number right here, which will be around 250,000 primitives, which is a little bit more manageable. But let's see what happens when we get down to 50. And you'll see we're down to 250,000 polygons here. We don't really lose too much of our detail. It looks a little bit better. Maybe we can go down all the way down to, let's say, 30%. And let's see what that looks like. And this will actually give us a better time of fracturing. So what I'm going to do is I'm going to wire this in instead into my RBD material. And let's take a look. And we're getting a lot quicker results now. And so this is what we end up with. Now, I have another problem with my initial fracture as well. I don't necessarily want to destroy the base of my statue. I really only want to destroy the head. So one way what we can do is we can split up this object into two assets. So before we actually go into the RBD Material Fracture, let's go ahead and set this up in a way that we're only working with this top asset and that we can turn this into a static object. So what I'm going to do is I want to group just the base here. And if I open up here and look at the inputs, you'll see that I do have three prim groups already. I have a head, I have the poly, and I have the stand. So if I come over here and use a split, wire that in, I can come over here and say, I just want the head. And you'll see that this comes in with the head. And I can actually work with this. We can fracture this part and keep it inactive. So let's go ahead and switch my ISO offset here into the split node. Come down here and let's move the RBD Material Fracture down, and we'll be fracturing even less material. So now we only have the top part. Now we have the scatter here, and now we'll have this. And as you can see, now we only have these elements fractured, and this will work really, really well. Before I carry on too far, let's go ahead and wire a null here, and we'll just move this null over here. And this is going to be called my out base. I have my first fracture done. So let's go ahead and fracture this again. So before I do anything else, I'm just going to drop another RBD Material Fracture. For this one, I don't need points. And I'm just going to go ahead and wire these in appropriately. And before I cook, let's go ahead and get rid of the second fracture again. And on the first fracture, we're going to call this second _ fracture. Now let's go up here and I want to enable fracture per piece, and let's go ahead and cook. Now this time I did not use input points, so we're going to get a little bit of a different look, but if you take a look over here, you'll notice that our pieces are being fractured, our big chunks are being fractured individually since we hit fracture per piece. So this is actually what we end up with. And it looks pretty good. A little bit too many pieces with too little of detail. So let's go ahead and play with this a little bit. And just know that as you guys play with the settings here, you're going to start to have some interesting things start to come up. So one of the things that I tell my students is watch out, because you're going to start getting artifacts on your objects. The higher resolution the object is, the more issues you're going to have. But let's go ahead and try and add some more of detail into this. Down and click on interior detail again. Now I'm aware that I haven't been using the edge detail along the lines. That's because RBD Material Fracture actually does have an issue for the noise along the edges. We'll try adding some detail here in 2 seconds. So, but one thing I want you to be aware of though is you will start to get artifacts as you guys start to use these settings, such as this one right here. That's an artifact. Oops, sorry. We have an artifact right here. So you're going to start getting artifacting. And there are some workarounds, but this is an issue with the RBD Material Fracture. And this is actually one of the reasons why I don't use the RBD Material Fracture that often, but for the purposes of this tutorial, it's going to do a great job and go a long way. So one thing I can do is come up to the first fracture, and let's see what happens if I do turn on the edge detail. And when we turn on that edge detail, I actually am getting pretty decent look here. So if I open up my exploded view, this is kind of where we're at. Feel free to play with this. Just know that if you turn on the edge detail in this one, which I actually did outside of this recording, I ran into some serious issues with my topology. So just be aware of that. But let's go ahead and move forward. So now that I have my two RBD material fractures and they're properly set with main fracture and a secondary fracture here, you'll notice that if I open up over here with a null, I'm going to go to my geometry spreadsheet, I have my pieces here, all are named properly. But if we come over here, you'll notice that I have two different glues. So I have my secondary fracture and I have my main fracture glue. This will be very critical for this next step. Just to get this out of the way, I'm going to open up with a split node. Let's go ahead and wire my constraints in. And what we're going to do is we're going to come down here and take the constraint tag, and we're going to split off the main fracture. So let's go ahead and just do a null down here. And we'll call this out main constraints. If I flag that, you'll see there is my main constraints. And if I do another null over here, I'll call this out secondary constraints. And these are my secondary constraints. We'll go ahead and color these green so we know I'm using those. I'm going to hit Shift-O here so that we have a background. And just to stay organized, let's go ahead and add in a sticky note. And I'll put this in here. We'll just go ahead and set text size to medium, shrink this down a little bit just to stay organized. And we'll call this constraints. To also make my life easier visually down the line, what we can do is I can come in here now and say on this node, constraints, let's go ahead and enable color, and we'll give this a red color. And on the bottom one, same thing, enable color, and we'll give this one a green color. And if I throw a null here in between, you'll see that I have both my constraint networks. We may manipulate these constraints later down the line, but at least these are good for now, so let's move on. Let's move on to setting up my statue now for fracture. So I'm going to move this over here. I'm going to go ahead and color that, and let's just give this a blue color. And then what we can do is we can call this over here, Shift-O. Let's go ahead and just copy this. We'll move that there, and we'll call this fracturing. For this one, we want to actually work off of the low res, and then we'll bring in the high res later. So I'm going to drop this down, and we're going to do an RBD Configure node. And if you take a look, actually we'll do the exploded view down here. What the RBD Configure node will do, it'll immediately pack your objects. So on the exploded node, you're going to see that all of my wireframe disappears. That's because these objects are now packed and instanced and ready for me to simulate. Off of this real quick, I'm going to go ahead and just do a null here. And we're going to call this out low res. But I want to set some groups first. And I don't necessarily use an RBD configure for this, even though you can come in here and just hit the active and set your group. I actually want to use a procedural way of actually inactivating my object. So what do I mean by that? If I come down here and I do an attribute wrangle here, I write this down. I'm going to create a variable float called height that equals at p.y. I'm also going to create a float thresh equals a channel float thresh. This is the threshold that these pieces will have to beat in order to be activated. Once that's done, let's go ahead and set inactive. What I'm going to do here is I'm going to do an I at active equals 0. And then on the next line, what we're going to do is we're going to start with an if-then expression. So we'll do if height is greater than or equal to the thresh, then at I at active equals 1. And so if we set this up like that, we'll just go ahead and move my parameter up here. Go to geometry spreadsheet. You will notice that we have points here that go well above 1.62, I believe, is the bottom. So if we go here, we sort this way, you'll see 1.56887 is the bottom. So what I can do is come over here and say, all right, 1.7. And what I can do is I can throw an RBD configure here. And I'm going to just move this piece into there. And if I come up here and use a visualizer and we'll say active, you'll see that now these pieces here are active going up, but these pieces are inactive. And if I come over here, I can say, all right, let's go 1.8. Okay, maybe not high enough yet. Let's go 2. And there we go. So now I'm able to actually set my active and inactive group procedurally. I can also come in here and create an expression that says, hey, these ones in particular also. But for right now, I'm going to just hold on to this. This should work. And we'll go into our simulation. So let's go ahead and I'm going to color this black so I know it's a visualizer. And this looks great. So let's color this green. We have my out low res. And let's go ahead and drop a DOP network. Let's dive in. Let's go ahead and start with a rigid body solver. Let's go ahead and wire that in. Let's go ahead and do a merge. And I want to merge a couple objects in here. We're going to do a static solver. And I need to flip these so that they actually simulate in that order. I'm using Shift R, or I can just simply just move these up. Up here, I'm going to go ahead and put a ground plane. And I'm also going to put in an RBD object. Go ahead and hold down Shift, click on the second one, and then hold down Alt, click, let go. And then you can map that down. That's how you could just merge those two together really quickly. RBD object, let's go ahead and navigate to my out base. We'll hit accept. There's my ground plane. I usually turn off my geometry here just because I don't need to see it. And that static solver should be set up. Let's go and do an RBD packed object. We'll call this one my sculpture. Let's, while we're at it, call this base. Wire this. I'm going to do a merge. RBD packed object here. This will be for later. We'll call this projectile. And this will just be one way to actually destroy. We may actually use forces. And before I forget, let's actually go get a projectile. So I'm going to go up a level. Let's go ahead and turn this off. And I want to create a projectile that's going to initiate my fracture. So let's just go ahead and start with a sphere. I'm going to do an attribute wrangle here. And let's go ahead and move the sphere forward and up, which means I have to go negative in the z-axis to get this right. So let's move that there. And then on the attribute, we'll just do @v equals channel v velocity. Let's go promote that parameter. And I'm just going to do, let's say, -20 for right now on the velocity. I'm also going to come down here and pack it. Be sure to move all attributes so that we get the velocity attribute. And let's do a null. And we'll call this out bullet. Cool. Let's dive back into my DOP network. And let's go and start adding in our elements. So I have my out here. Let's go and call this low res here, accept. And then projectile, we'll come over here and we'll call this bullet. Add the inherited velocity to my bullet. And there we go. Now I don't have the glue constraints in. We don't have gravity yet, so my object is just falling apart. So let's go ahead and start simulating this properly. So we'll do a gravity down here. And if I were to hit play, my statue will just fall apart. Okay, so let's go ahead and start adding in our constraints. So the first thing I want to do is add in a constraint network. And I want to start working biggest to smallest. We'll add in our glue constraint relationship. Let's wire this in. And let's go ahead and start with my main constraints. Hit accept. And if I hit play, it's still going to fall apart a little bit because I have little pieces here that are on their own. So just be aware of that. But let's go ahead and set this one up first before we set up the next one. So what I want to do is lower this down to, let's say, 1. There we go. Now my statue is falling apart. Perfect. Let's go ahead and add in the second constraint network. Also a glue constraint relationship. And let's go ahead and set this one to out secondary. And we'll lower this down to 1. And there we go. Now this piece is falling apart. And the big chunks actually have their own glue constraint. We can manipulate these separately to kind of get the effect that we want. So just having these strengths set to 1 isn't quite enough for what we want to do. So we need to manipulate these strengths. I'm going to return this second one here to 100. And what I'm going to do is I'm going to come up here and I'm going to turn off the display geometry. So we only can see the constraints here. And let's go ahead and switch the guide options here. So under the glue constraint for the first one, let's go and switch this color here to blue. And under the second one, let's go and switch this one to yellow just to see it better. And if I hit play, you'll see what's happening here, that this constraint is not actually animating at all. You'll see that it's actually not falling apart anymore. And that's because the constraints here are set to 100. And they're taking over where these are lacking. So what I can do is we can create an impact point here that says at the impact of this ball, I want you to break apart this way. So to do that, let's go ahead and create an SOP Solver. And I'm going to wire this into my solver input of that first constraint network. And you'll see immediately this disappears. I'm going to disable this one for now. And let's dive into the SOP Solver. And I'm going to move my output here over here to my relationship geometry. And if I go up a level, you'll see that my constraints return. But in this SOP Solver, we can do a couple of cool things here. One of the first things that I can do is I can create, let's say, a sphere object. And let's go ahead and just move the sphere into about right where the impact happened. And to see this better, what I can do is do a null here. Let's flag this. And if I hit play, you'll see that we get these points right here to show up. These are called impact points. But when these points happen, these impact points happen, you're going to actually get some attributes here that are useful. For instance, you're going to get this data path here that says, hey, an impact has happened. But you're also going to get this object ID. And this is going to be decided upon what object created this. So if I come over here and say blast, you'll notice I don't really have anything here that I can use. But what I can do is here select. What I can do using my two windows here is I can dive into my network here. And this will be easier. So I have this pinned to number 2. So I can do it this way. And I can say at obj ID equals 3. And we'll delete non-selected. And what's happening here is I'm only seeing where that ball initially hits now. Right there. So these are the initial hits of the ball. And I can use this data right here, and I can say, hey, this is where I want my object to be. So I'm just going to go ahead and template this. And let's go ahead and look at my sphere. And you can see that I can move my sphere around so that it encompasses this area here. And y-axis. Cool. And I can use this to create a group. I'm going to switch this to points for right now. To set this up, let's go ahead and I'm going to flip this here. We'll call this delete point. I'll call this $OS, and we'll do bounding box here, bounding object, and I can do a blast. We'll flag that. We'll switch this to my delete point. Okay. And you'll see immediately the points here are deleted. What we could do is at that impact point, which I believe is 9, we'll double check here. So 9. Here, I'll just say, hey, uniform scale here. And let's go up to, let's say, 25 and go really big. Set that keyframe. Flip this to out here. There we go. That's really fast. So just be aware of that. If I do this, I'm going to get rid of all the templates, hit escape. This is what we're left with. Cool. So my constraints are kind of deleting. However, I don't want this happening before frame 9. So a neat little trick that we can do here is I'm going to do a blast here. And what this will do is it will delete the sphere. So I have sphere, delete it, and then a switch node. And I can come in here and I can keyframe this switch node to frame 9, or I can write an expression here that says parentheses $F is greater than or equal to 9. And what that's going to say is, so if I look at delete point right here, you'll see that the group is set right now. So I actually probably have to flip these two. So if I hit Shift R, they'll flip. That's what I want. So, okay. And now you'll see that on frame 9, it'll start deleting. Okay, so let's go up a level here. And let's go ahead and see now what happens with my ball. All right, so we do have a problem still because I turned off that secondary constraint, but the first constraint is now working. Let's go turn on that secondary constraint. Actually, we'll stay up here and we'll do it here. Let's go up a level. Let's go turn that on. I'm going to lower this down to 1 for right now so we can see what happens here. All right, so we're getting somewhere now. But I want these big chunks to break open into these little chunks. What I want right now is to actually increase the amount of detail that I actually have here so that we can see this better. If I open up here, you'll see that there actually is no fracture point going through. So if I go over here so you can see it better, you know, this is a really big piece here. So I actually kind of want to increase the amount of fractures that we have. So we'll just back up a step. And that's the cool thing with Houdini, is completely procedural. So if I just come down here, let's go to this RBD Material Fracture node. And let's go ahead and increase this to, let's say, 25. This is where we're going to get a lot of our pieces. And we'll let that cook for a second. Just be aware, though, as I increase this, the detail could get thrown off. All right, cool. We have this. Let's go ahead and move that back together. Seems to be holding together for the most part. And if I come down here and I look at my constraints, there we go. We have a lot more detail in those constraints. So let's go ahead and dive back into my network. Let's go ahead and hit play and see what happens with the constraints. And you'll see that these constraints are holding together. Let's look at this one right here. And they're holding together all the way till they break. Okay, so in order to get these to break the way we want to say, hey, let's start losing our strength at a certain point in time so that they can coincide here. This is a nitty and gritty way of doing this. We can actually make this even far more procedural, but I want to keep it simple so that you guys can understand what's actually happening. So let's go ahead and dive into the SOP Solver, in which I already have the SOP Solver 2 open here. And what we can do is we can write an expression that says, hey, at a certain time, let's start losing strength here on our primitives. For instance, if I open up my geometry spreadsheet and I am currently on the Out tab of my SOP Solver 2, you'll notice that there's a lot of strength here. The strength of these pieces is actually quite high. And so what I can do is create a series of variables that run through an expression that will lower these strengths at a certain time. So let's go ahead and do that. I'm going to write an attribute wrangle here. And what I'm going to say, I'm going to run this over primitives. Let's notch this in. Let's call this strength trigger, and we're going to write a series of variables. So let's go ahead and do, the first one is a float frame equals f at frame. Let's set another variable here, trigger. So this will be our trigger point at time equals channel float trigger. I also want to create a random number generator. So let's do float rand equals rand 0 at pt num. I know I'm in primitives, but this should still work. Float rand big equals fit. This is going to take that random number and actually put it within the parameters that I want. So let's do rand between 0 and 1, and we want to fit those between a range of channel float min and then channel float max. Cool. Let's go ahead and promote these parameters up now. And obviously this isn't working yet. Oh, I'm missing a parentheses here. Okay, obviously this isn't going to work yet because these are just variables. We actually have to put these variables through an expression. So let's do an if-then expression that says, if I come over here, that if the frame is greater than or equal to the trigger, then let's say the f at strength equals rand big times channel float strength scale. Now, this is an interesting bug right here that we have. But if I promote this next parameter here, I have a funny feeling that if I hit 9 here, it fixed. Sometimes when I do this, I actually have to go out and then reset the simulation in the .NET, then come back, and it'll bring my strength back. I've noticed that in Houdini 20 a lot more than in previous versions, but it didn't do it this time, so that's good. And let's go ahead and set this up to, let's say, a minimum of 1, let's say a maximum of 4, and I'm going to start with a strength scale of 100. And if I hit play, you'll see that, boom, right at frame 9, we start getting random strengths here off of my parameters here. And we're just going to start with these numbers and see what we get. Let's go ahead and take a look. Right now, I am only looking at I don't have a link. So I'm just going to switch this over here to number 2. And let's take a look. And you see that they are keeping their strengths. They're keeping their primitives here. They're not breaking yet. But when they come into contact with the ground now, they're breaking. Pretty cool. So let's go take a look at what that looks like upstairs. So we'll move this into .NET here, and boom. And so what we're having is some of these big chunks are going to fall now, and they're going to break on their second impact. And hopefully now you have an understanding of how we can just write some simple expressions to actually maneuver our glue constraints so that they break in a certain way. And of course, there's so much more that we can do. Let's come up here, and I'm going to dive back into this .network. And let's go back into the SOP Solver. And right now, we're just using a simple blast node to destroy these primitives. But what I can say is under this delete point, let's go ahead and disable that for right now so we can see this. We could do something similar where the strengths change within this area here. So we call this delete point. Let me go ahead and change this name here to strength alter. Let's get rid of this blast node here, and we'll write an attribute wrangle here. And keep in mind, these are on points. So the next thing that I have to do here is do a group promote. I'm going to show you what I mean. Let's go over here to, let's say, frame 23. We'll go frame 17. And what I want to do is say, I want to go from points to primitives. And, oh, that's because here. So point, strength, alter. Let's go up here. Let me just go ahead and just reset the simulation. Sometimes, there we go. And you'll see strength after. You see the glue constraints get a little weird here right now because I have them broken. So and we'll just slide this in, see if I can actually get the result that I want. Sometimes when I promote here, it actually doesn't work. I'll make sure that keep original group. All right, let's see here. And let's go ahead and go into this SOP solver here. And I'm just going to take this expression here. So let's just go ahead and copy all this. And we're going to run this over the strength alter group. Make sure I'm in points or in primitives. And we'll do the strength alter here. Make sure that it should be right. And now let's go see what we get when I do this. And you'll see the way they're breaking is a little bit differently now. We're probably getting a really interesting look, actually. Let's go see what that looks like. It's not bad. Let's play with this a little bit. So on this sphere here, and I'm just going to flip this into 1 for right now. And I want to move the center up a little bit. And maybe over. Right there. Okay. Let's see what we get. Play with these parameters a little bit. So let's move these up and actually drive this in now. So we'll say 9. And I'm going to say 1 to 4 to get started. And let's just start with 100 and see what it looks like. Okay, it's not breaking at all. So we'll start with 10. Breaking a little bit more. Let's increase the number here to 2. Maybe 3. Let's do 0. And I'm just playing with these until I get the look that I want. Maybe we'll come all the way down to 1. Let's go up a level and see what it looks like. Maybe we'll play with this even further. Let's go ahead and dive in. And let's go ahead and maybe here on the primary, let's do 0.1. Let's increase the half-life to 0.5. We do 0.05 here. Let's do 0.75, and I'm going to reduce this to 0.5. There we go. I'd like to get these pieces to break so this whole thing comes down, so I'll keep playing with it. So let's say 0.1. And we can also play with the group here. So let's go ahead where it gets to this one to 27. I'm going to move that over to 20. Let's go 15 just to make sure it's big enough. Maybe if I come up here and actually, let's increase the density of my object here to 1,000. There we go. I just needed enough force for it to come in and actually start to break apart. But as you can see now, my secondary fractures are actually breaking very quickly now because there's a lot of contact happening. So I may have to go in and edit those. So let's go ahead and do that. Let's go up here now. And let's go ahead and increase the strength here to 1,000 and see what this looks like. Now they're holding together here. So maybe we'll do together, let's say 200. And we'll say 150. There we go. And there's more pieces are actually holding together right here. And it starts to fall apart there. Let's go take a look at what that looks like. And now we're getting a much more accurate look here. Let's go to create this into the, let's go ahead and add this into the high res. So what I'm going to do now is I'm going to grab a high res right here. We're going to do a transform pieces. Let's go ahead and use these points here. And let's go ahead and hit play. And now we have a high res fracture. Let me know what you guys think in the comments below. This is the 5th video in this series. I wanted to do a longer one for you guys so that you had an opportunity to really explore what it looks like to throw a fracturing system on an object of your choosing. Don't forget to like this video and subscribe. And until next time, always be creating.